Suppose we're given a function f that is written in this way. So the function is a product of two scalars because each of these is the inner product of two vectors. So both of these two are scalars, and it's just a multiplication of the two scalars. So it's still a scalar. So this function f is multivariate in the scalar valued function. The question is to find the gradient of f and the Hessian of f at any given point x. We can first show that this is just a quadratic function of x, and it's you can see from here that it depends on x in the second order or the second degree of x. So to see that, we can make a small change of the problem, because this A transpose times x is the inner product of x, and the inner product doesn't change if the order of these two vectors change. So that means A transpose x is also x transpose A. Okay, so these two are the same. And now you can see that the multiplication of these vectors, essentially you can treat all of them as special type of matrices. Because of the association rule, it doesn't matter which order you take the product or the multiplication. So you can just completely remove all the parentheses, and that becomes x transpose A, B transpose x. And I put the A and B transpose in between together, I'll get this. And remember that this middle one is a matrix because A is a column vector. That's A and that's B. So it's a matrix there. And if we have a matrix in between x and x, we know that we can always convert it to something, some kind of quadratic term with a symmetric matrix in middle. Okay, and that symmetric matrix is this matrix plus the transpose of this matrix itself, and then divided by 2. So this is our matrix. Let's say we call it A. So I can construct this Q, which is the A plus A transpose divided by 2. Okay. So that's how we got this. We can rewrite this in terms of that. Okay, so this AB transpose is just take the transpose of this. So that becomes AB transpose. If I take the transpose of this, I'll get BA transpose. So that's what we need. Okay, so that's how we got the BA transpose. So this f of x can be written in this way as well. And now this is like the Q matrix we talked about in class. So it's 1/2 times x transpose qx. And in this kind of, for this kind of quadratic function, the gradient is just the q times x, which is just this matrix copying here. And the Hessian is just this matrix itself. So that's this.